All right, so this one happens to lie in the southern hemisphere, so I'm going to draw it there. Although if you drew it in the upper one, that's fine too. You're just using it as a model. Okay, but you want to find, so here's some city right here. Okay, you want to assume that the Earth's radius, so now when we look at our equation, we're going to use the equation for circumference that involves radius, so 2 pi r. Okay, and so when we set this, we know that this distance from the equator, so we know this distance right here is 2616. So that is our S value, right? That's our arc length. Okay, we don't know our M value, so we're going to leave that as our variable, and then 2 pi, our radius was given. And so if we solve this equation for M, we could do it a couple different ways. You could manually do it. You could use the solve feature of your calculator to do it as well. Okay, so I'm going to set it up using the solve feature. So if I hit this algebra tab, F2, use my solve feature, type in my equation. 2,616 is equal to, and I'm just going to use x for this, x divided by 360 times 2 pi. My pi button is this second function, the caret symbol, all times the radius, 6378.1. Okay, then I want to use a comma x to identify to my calculator what I want it to solve for. Close off my parentheses to end the solve feature of it. And so now when I hit enter, I get my solution, 23.5. Okay, so would it make sense that that would be the latitude as well? Yeah, so it's exactly the kind of the mirror image of that Tropic of Cancer. Okay. Questions on those? Be prepared to see problems involving that. But it winds up, again, being a relatively simple calculation. It's just an arc length problem.